discussion on environmental engineering. We want to see the whole environment engineering. Let's start. First of all, we need to know what is environment. So environment has different meanings regarding the discipline. In environment engineering, environment is the surrounding in which a person or animal or plants lives. This environment can be categorized into two: natural environment and built environment. Natural environment encompasses all living and non-living things occurring naturally in the area. For example, national parks, those are the natural ones which are God-made, we term as natural environment. The second part, or the other category for environment, is built environment. This refers to the human-made surroundings that provides the setting for human activity. For example, buildings, cities, and supporting infrastructure, areas such as transport, water supply, and energy supply. So we are referring to the structures that are built or constructed by human beings. So these are man. So this environment on Earth, the Earth that we are going to focus on to see how is constructed, or how, what are the parts of the environment. So there are four spheres of the Earth that are of interest to our environmental engineering, which are the lithosphere, the rigid outermost shell of the Earth, hydrosphere, the second part, which consists of water, water on, under, and over the surface of the Earth, and the atmosphere, a layer of gases surrounding the Earth, and the biosphere, which is some of living organisms on Earth. So environment, they are combined to become ecosphere, and can be remembered as easily as corresponding to the rocks, water, air, and life at large. So let's see on how human being interact with the environment. Human society and environment interact with each other. Human impacts, that is anthropogenic impact, on which the environment refer to the impact of human activities on biophysical environment, biodiversity, and other resources. Those activities include agricultural practices, whereby you can see deforestation, agricultural chemicals, soil degradation, to see on how they have impact on our environment. Also fishing, where we can see the overfishing, irrigation, livestock production, energy industry, where climate, you can find that climate can change due to this energy industry, manufacturing, mining, which lead to erosion or loss of biodiversity, contamination of soil, transport, whereby use of fossil fuel, air pollution will be the result if this transport will have impact on environment. Environmental engineering. The terms, if they are put together, we can see how they are related. It's our focus to see how engineering will have impact on the environment. So engineering is the application of scientific principles for planning, designing, and operation of structures, equipments, or systems for development of and the benefit of the society. What is environmental engineering? This environmental engineering, as you can see, is a summation of the two, environment and engineering. So environmental engineering is the application of science and engineering principles to protect and utilize natural resources, control environmental pollution, improve environmental quality to enable health, ecosystems, and a comfortable habitation of human beings. It is based on multiple disciplines, including biology, medicine, hydrology, biology, engineering, management, ecosystems, and laws. So environmental engineering involves water supply, waste water management, solid waste management, air pollution control. This is where engineering comes in. Noise pollution control, radiation protection, environmental sustainability, public health issues, environmental impact assessment, climate change adaptation and mitigation. Lastly, and the renewable energy. So this our environmental engineering will be focusing on the items indicated. Developmental activities such as construction, transportation, and manufacturing not only deplete the natural resources, but also produce large amount of waste that lead to pollution of air, water, soil, and largely will come up to the global warming acid rains. Untreated, improperly treated waste is a major cause of pollution of rivers and environmental degradation, causing effect to health and loss of crop productivity. In this course, you will study about the major causes of pollution, their effect on environment, and the various measures that can be taken to control such pollutions. So we need to understand some terms which will be discussed in our discussion: pollution and pollutants. Human activities directly or indirectly affect the environmental adversely, such activities are automobiles emit oxides of nitrogen, sulfur dioxide, carbon dioxide, carbon monoxide, and a complex mixture of unburnt hydrocarbons and the black soot which pollute the atmosphere. This is the only one example out of many which shows how human activities pollute the environment. Pollution may be defined as the addition of undesirable material into the environment as a result of human activities. So the agents which cause environmental pollution are called pollutants. These agents which cause environmental pollution are called pollutants. As you have said, pollution is defined as the addition of undesirable material, unwanted material into the environment as a result of human activities. So a pollutant may be defined as physical, this can be physical, chemical, biological, or biological substance, which unintentionally has been released into the environment, which is directly or indirectly harmful to humans and other living organisms. So that is the pollutant. If it happens that this pollutant is given to the environment and has to disturb the natural environment, is termed as pollutant. So let's see the types of pollutants. Pollution may be of the following types. Types of pollution. Let's see on how this environment can be polluted. First of all, this environment can be polluted through the air, that is air pollution, noise pollution, water pollution, and soil pollution. But also there is thermal pollution, that is from heat pollution, and radiation pollution from radiations, or the earth the environment can be polluted. However, in this context, we discuss the three of them, that is air pollution, water pollution, and soil or land pollution. Now, to start with, we want to see on how this environment can be polluted through air. For air pollution, causes of air pollution can be natural, for example, forest fires, and the second can be human through causes by human activities, for example, combustion of fossil fuel as energy. Major sources of air pollution remain industry. However, the major sources of air pollution remain to be industrial processes and motor vehicles. Motor vehicles emit a lot of gases which are counted as air pollution. Common air pollutants. One is ozone. This ozone is oxygen 3 found in the Earth's upper and lower atmosphere. This ozone shield is the only thing keeping away that harmful radiation. So it's like some will term it is this ozone is like a blanket that is covering the Earth, the upper where in the upper atmosphere. This ozone has a task to protect the Earth from the harmful solar radiation. We know that the solar radiates energy by which we can get light. In the lower atmosphere, this pollutant can cause chronic respiratory tract infections, eye irritation, coughing, shortness of breath, nausea, wheezing, and headache. So we will see on how these common air pollutants, if they can destroy this ozone, oxygen 3, which is protective layer to keep the earth safe from the harmful rays from the sun. We have to discuss and see how is it affected by the common air pollutants. Earth naturally is surrounded by gases called air, which forms the atmosphere. The atmosphere is a complex, dynamic, natural system, essentially to support life on Earth. The air interacts with the water and land. Acid rain falling on the ground is a result of air pollution. So let's see how this air pollution occurs. Many pollutants such as particulate matters, which are heavy metal and ozone, are able to influence water quality and ecosystem functions. On the other hand, polluted rivers, lakes, and sewage systems can cause air pollution in their surrounding areas. Therefore, it is important for an engineer to understand the air and its related quality issues. That's why this matter comes in for the engineer, where and how the earth, the environment can be polluted, in a position to mitigate or to control the environment. Composition of the atmosphere. So the atmosphere is a mixture of many different gases, but mostly it consists of molecules of nitrogen and oxygen. By volume, about 78% of the dry air is nitrogen, and about 21% is oxygen. The nitrogen and oxygen combine to make up approximately 99% of the atmosphere, which we call it air. The remaining 1% of clean air is a mixture of several other gases. Most of the remaining 1% of the air, about 0.9%, is inert gas and argon. The rest of it include carbon monoxide, methane, hydrogen, helium, neon, ozone, and numerous other gases in trace, very small amount. So the composition of air is 78% nitrogen, 21% is oxygen, and 0.9 is argon gas, 0.0535 is carbon dioxide. In case of air pollution is the introduction of substance, or these we call pollutants, in the air which are harmful to human and environment as well. So causes of air pollution may be natural, such as volcano eruption, or man-made, such as fossil fuel in power plants, industries, and transportation. Pollutants can be solid, liquid, or gaseous. So one can see how the industry can lead to air pollution. This one is a vivid example of smoke being produced by the industry. You can see how it can lead to air pollution. Oh, carbon dioxide, carbon monoxide. This is caused by incomplete combustion of fuel and air, most of which comes from motor vehicles. It is colorless, odorless, non-irritating, but very poisonous. So it blood and reduces the transport of oxygen through the bloodstream. So you can see how dangerous this carbon monoxide is to a human body. Also, this carbon monoxide can lead to cardiovascular problems. At high levels, asphyxiation can in indoor environment due to poor heating system and inadequate ventilation. For example, during cold seasons, people do use this charcoal. It's an example of this. If there is no complete burning of charcoal, you can come up with a result of carbon monoxide. There are some cases where people happen to die due to inhaling this carbon monoxide. The WHO air quality standards for carbon monoxide is 30 milligram per meter cubed. That's 1 hour average, and 10 milligram per meter cubed. That is 8 hours average. Other pollutants, that is oxide of nitrogen. Oxides of nitrogen. This results from high temperature combustion processes, e.g. cars and utilities. They affect the respiratory system, leads to fatigue, combined with the water vapor to form nitric acid and falls as acid rain. Nitrogen dioxide is also produced naturally during thunderstorms by electrical discharge. So these are the oxide of nitrogen. Okay, the WHO air quality stands for nitrogen dioxide is 20 milligram per meter cubed. That's 1 hour average, and 40 milligram per meter cubed annual average. Production for this should be our standard. The two thresholds represents both short-term and long-term effect of the pollutant on human health. Let's see for sulfur dioxide. Preliminary caused by burning of coal and petroleum. Also many raw materials such as aluminum, copper, iron, and ore contain sulfur. Their extraction produce sulfur dioxide. Naturally, sulfur dioxide is produced by volcanoes. Like nitrogen oxide, sulfur dioxide can be converted into sulfuric acid and follows acid rain as well. So sulfur dioxide can accelerate the decay of building materials and cause respiratory disease and death. Can also damage crops. The WHO air quality stands for sulfur dioxide is 20 milligram per meter cubed. that is 24 hours average, and 500 milligram per meter cubed, 10 minutes average. Those are the standard for sulfur dioxide. For some gaseous pollutants, source and their effect. So this chart describes, illustrates how source of pollutant and how harmful it is, or the respective effect to our environment and our life in general. Carbon compounds, carbon monoxide and carbon dioxide. The source, the automobile exhaust, burning of wood and coal. The harmful effect can be experienced to respiratory problems or greenhouse effect. Sulfur compounds, power plants. The source can be power plants and refineries or volcanic eruptions, that is natural. As well, they can be harmful to the human beings on the respiratory systems. Also, chlorophyll in plants, so the plants can become yellowish, and they can result into acid rains, nitrogen compounds. The source is motor vehicle exhaust, atmospheric and the atmospheric reaction. The effect to human being can be irritation in eyes and lungs, low productivity in plants. Acid rain damages material, metals and stone. As we found that it can accelerate the decay of materials. Hydrocarbons, which are benzene and ethylene. The source is automobile and the petroleum industries. The effect as well is through the respiratory system. Also can result into cancer-causing properties. SPM, that is suspended particulate matter. This can be solid or liquid in the air. It can be flash, dusty, or lead. This can be due to thermal power plants, construction activities, metallurgical processes, and automobile. The effect would be poor visibility, breathing problems, lead interferes with the development of red blood diseases and cancer. Smoke, that is formation, leads to poor visibility and aggravates asthma in patients. Pollutants which are due to fibers, and which is cotton and wool. Source is textiles and carpet weaving industries. The effect would be to the lung disorders. So the particulate matter, this one refers to fine particles, solid or liquid, with a diameter of 10 micrometers or less, found in the air. Can be either natural, that is from volcanic activities, or volcanic eruption, dusty, due to storms, etc., or man-made by burning of fossil fuel, can come up with a particulate matter. 32 can be primary sources of fuel burning in vehicles, can give a particulate matter from power plants, where also construction of activities, where we construct big buildings, oil refineries, railway yard, marketplaces, industrial and commercial processes. Those can be source for particulate matter. All particles with 10 millimeter or less in diameter are denoted as PM10. Particulate matter 10. And those with the 2.5 millimeter or less in diameter are denoted as PM2.5. Larger particles are problematic for respiratory system because they can be trapped in the upper respiratory system, producing a clogged nose and a scratched throat. Fine particles may make their way deeper into the lung to cause the breathing problems and are absorbed into the blood streams to affect many organs. So the WHO air quality stands for PM10 is 50 grams per meter cubed in 24 hours average and 20 milligrams per meter cubed annually. So these are the standards that are set to minimize production of this particulate matter. And for PM2.5 is 25 milligram per meter cubed within 24 hours average and 10 milligram 3 meter cubed annual average. It is not clear about the health risk caused by particles with a diameter less than 0.1 millimeter, and so standard is set for PM1. Lead and other metals such as tetraethyl lead is used as an anti-knock agent in petrol for smooth and easy running vehicles. The lead particles coming up from the exhaust pipes of vehicles is mixed with air. If inhaled, it produces adverse effects on kidney and the liver and interferes with the development of red blood cells. If mixed with water and food can create cumulative poisoning. It has long-term effect on children as it lowers intelligence. See the risk of lead to our growth of our children. Lead and other metals. Oxide of iron, aluminium, manganese, other metals have adverse effect due to deposition of dust on plants during mining operations and the metallurgical processes. They create physiological, biochemical, and developmental disorders in plants and also contribute towards reproductive failure in plants. Volatile organic compounds, VOCs, result from combustion processes and evaporation of gasoline, vapors, and solvents. They contribute to global warming. In sunlight, they combine with the nitrogen oxide to form ground ozone or smog. So smog is a mixture of fog and smoke, which occurs in some busy industrial cities. Fog means tiny drops of water in the air which form a thick cloud that make it difficult to see things. Ozone irritates eyes, aggravates respiratory ease, damages crops. Other air pollutants. Chlorofluorocarbons damages the ozone layer, which protects life forms from harmful rays of the sun. Formaldehyde, benzene, asbestos, manganese, dioxins, and cadmium, carbon dioxide, ammonia are other air pollutants. So, secondary air pollutants, we have been discussing about the primary air pollutants. Let's see now the secondary air pollutants. Air pollution results from natural causes. Gases formed by chemical reaction in the air, typically by the action of sunlight on primary pollutant, e.g. ozone forming, that gives rise to photochemical smoke. The other part is photochemical smoke is air pollution caused by the effect of strong sunlight on nitrogen dioxide and hydrocarbons emitted by motor vehicle, creating a harmful haze of minute droplets in the air. And the secondary air pollutants. Very important here to note ways to reduce air pollution. See now, see how we can reduce this. So techniques without using emission control devices. Replacement of wind, geothermal, hydroelectric, and solar unit instead of using fossil fuel fires units can help to reduce the risk of polluting the environment through air by replacing the fossil fired unit to wind, geothermal, hydroelectric, and solar unit. Or another technique can be change in fuel. For example, use of low sulfur fuel instead of high sulfur fuel. Good operating practices. Housekeeping. All these can contribute to reduce the production of air pollutants, which end up polluting the environment. Drive less. Another technique to reduce the production of air pollution. One can walk or ride a bike, shop by phone or mail, ride public transport, instead of each one having his or her own vehicle, with the production of air pollutants. Buy air-friendly products. Another technique. Buy products that are water-based. Buy water-based paints with a brush instead of sprayer will reduce the production of air pollutants. So air pollution control, that has been we have discussed already how one can reduce. Let's see on how one can control. Early approach, particularly removal air by use of air filters. So if you use air filters, it's a means of controlling air pollution. Sulfur removal. Can you remove sulfur by using scribers? In our construction, you have to use scribers to remove sulfur. Also, nitrogen oxide reduction can be controlled by the help of catalytic converters. This can well be illustrated for the car pollution, where the gas emitted after combustion, we have got the catalytic converter. Sometimes it is muffler for the exhaust system, where the air will be converted. It's catalytic converter. Hydrocarbons control can be controlled by afterburners to eradicate these hydrocarbons. Commonly used method for air pollution control or particulate cyclones, or fabric filters. This is it, as you can see how it's installed to control this air pollution. And wet scribers. Now this has been imposed to reduce the air pollution. Instead of erupting to the air, cyclones have been installed to control the air pollution. So electrostatic precipitators also is a filtration device that removes fine particles like dust and smoke from a flowing gas using the force of an induced electrostatic charge, minimally impeding the flow of gases through the unit. So you can see how the electrostatic precipitators, they are just to make sure that the gas that is passing through is being filtered before coming out. So also fabric filter for industry, for cotton, cloth. Fabric filters also called bag houses and bag fitters are air pollution control devices. They remove particulate matter from a gas stream by passing the dirty air through a layer of cloth. So the cloth will not allow the fabric pass through. So the residue will remain on top of the cloth and the fresh air will pass through. Wet scribers, as a means of controlling the air pollution, are effective air pollution control devices for removing particles and gases from industrial exhaust streams A wet scriber operates by introducing the dirty gas stream with the scribing liquid, typically water. So this particulate or gas are collected in the scribing liquid. So a liquid is put there before this air comes out. It must pass through this liquid, so the pollutants will be captured by the particulate will be captured by the gases, by the liquid, so the fresh air will come out. See? So clean fuel gas to start. Heater, you can see scribe by plastic somewhere here. Fuel gas containing sulfur dioxide enters this fiber. So the residue will be, if there is a liquid inside here, the air, so the fresh air will go up there, the residue will remain at the bottom. Lamson salary. Scribing unit, salary here, to wash water. For gases, absorption towers. This is a device which reduces bad odor and volatile organic compounds by collecting and absorbing activities. Absorption towers. This refers to a device which reduces bad odor, bad smell. So also some kind of pollution. For gases, thermal incineration. The thermal oxidizer, also known as thermal oxidizer or thermal incinerator, is a process used for air pollution control in many chemical plants that decomposes hazardous gases at a high temperature and releases them into the atmosphere. Thank you. This makes the end of air pollution. Sasa baada ya pale sasa siku ile bora niliweza, leo haitaki kwenda. Baada ya pause hapa si stop. Ndio. Sasa hapo